Okay, today on Captain Chaos's laboratory we have the Scare-Ousel. This was sent in because it has some issues. It's currently really non-functional. Lauren sent it to me. It has, because she sent me some pictures, which I'll include the still shots in here. It has a broken gear. It has a burnt resistor, which makes apparently the lights don't work, which possibly the resistor. And it doesn't have any sound. So she sent me the unit without the power, since I have plenty of 4.5 volt power supplies, and a baggie of parts. She tried to take it apart herself and work on it, which is why it's all disassembled on the bottom. So we're going to see if we can actually make it function. Find out what caused the resistor to burn, which generally is a short. Sometimes when a light gets shorted out, it now has these and it's pulling more power because there's less resistance across all the lights if they're in series. And then the resistor overheats. I've seen that before. It's not very common though on an LED. Usually what happens is when one burns out, they all just quit working. I have seen it where the wires have just touched each other. They use cellophane tape or hot glue or resin as an insulator. It degrades and then the wires touch something else. Usually it touches the hot power to the negative power and the resistor overheats and burns. So, cracked gears, common. See them all the time. So, and not that big of a deal. So we got some screws in the bottom. Let's see what we got in the little purple bag. Probably the cover for the center piece. I haven't opened any of this. I just took it out of its box and set it on my bench. Yeah, here's the centerpiece with a couple of screws, it feels like. There's the speaker. Speaker definitely doesn't work since there's no wires attached to it. And here is the gear plates. Gear plate, the gear. I'm trying to get to that broken gear. It's right there. There it is. That's all that's in here. So I'm going to put the speaker plate back in here just so I don't lose it, since there are screws still stuck in it in case I decide to fall out. Here's the interesting one. There's the broken piece. Focus. There you go. Which attaches there. This is a very unique gear. Honestly, it's the first time I've seen this gear on any Lemax product. But when it's put in, like so, it has a little notch. So it's got a keyway or a cam. I'm trying to hold it better, which drives some moving mechanism inside. And also what's surprising is this uses mostly just fine teeth gears. They're not very thick on the tooth. So it's got some rarities that I haven't seen before. That might be due to the age. Let's see, does it say the age on the bottom here? No. Has a lot of stuff written in it, I'll tell you that. On newer Lemax, everything that we printed on those pieces of paper that are always attached to the cord is stamped into the bottom. So, there's the motor. There is one broken wire. Let's get some more light in here. So we have a set of wires that are both white right here. I'm assuming they're coming off of this chip. This chip is most likely the speaker. It's the amplifier chip. We got a couple of large capacitors, a small one down there. You got the blob chip right here. And we have a couple of resistors and another, it looks like either a resistor or a diode. It looks like it might be burnt as well. And on this little remote board, we have transistor, two types of diodes, a regular and it looks like a Zener, and a resistor. I'm going to assume that these wires, which go up the center underneath this circuit board, so let's get back in the frame, up in that hole right there, are probably the light wires. Probably make the lights flash patterns. So it's an interesting piece, I'll tell you that. So of course, we need to take it apart, diagnose the causes, and I gotta try and find that that resistor. That's gonna be the fun part. Or sorry, not the resistor, the gear. I mentioned in the previous video, I'm trying to talk to a guy about 3D printing some of these gears that are hard to find. This might be the first one we attempt. The biggest issue is the teeth are so close. We're going to see what we can do. If not, there's some other ideas that we have in hand, but we'll have to see when we get to that point. So, alright, I'm going to prep this and go grab a power supply because I thought I had one sitting on my bench. I don't. That's me being prepared. And then we're gonna try and get some power so we can maybe do some voltage checks to find out what might be causing, and resistance checks to what might be causing the burnt resistor that's up inside this hood. So, shall return shortly once I go grab a 4.5 volt Lemax power supply that has magically disappeared from my bench, and a meter which also has disappeared from my bench. But I know where that one's at, so I shall return in just a moment. Alright, we're back. I got a power supply and meter. I haven't plugged in or tested anything yet, and I'm not going to plug it in at the moment. Just doing a visual inspection of the circuitry here and the circuitry in here. I don't want to plug it in for any more fear of any more damage to the unit itself. I'm going to try and show you as best as possible what I can find. It has 3 burnt resistors, one up here, one down here, and one in here. And it also has some broken wires, which isn't a big deal. These 2 wires that are right here, there's one, most likely are a speaker, since they go to the chip, which is right here, which I'm going to show you all in a second, which is a sound amplifier chip. This has 2 blob chips. There's one down here, which you'll see in a moment, which is the main blob chip, which controls the sound and most of the lights. Then there's another blob chip up here, which that blob chip was also used on some Department 56s. I'm assuming based on what it does. It takes an incoming light signal and then alternates the lights back and forth. I think it's called an H-bridge or something similar, is what it's doing. It's just a light alternating chip. But anyhow, there's a lot of burnt stuff, and I'm afraid to energize the circuit because if anything is too horrible and that main blob chip gets fried, the one down here, this unit's useless. So I'm going to try and trace all the wires, trace the 3 circuit boards, figure out what everything does, try and isolate what each of the burnt resistors go to determine why they're burnt. Resistors only usually burn when you overcurrent them. This is only 4.5 volts. All the resistors I can see go to the lighting, which indicates to me that there's something shorter than the lighting. So instead of the lighting going on and being on, they're either really dim or not on at all because there's a dead short and that resistor is getting extremely hot on two of the resistors. On the third resistor, which is on the board, it's actually the resistor that comes off the speaker, the sound chip. And the reason that one might be burnt is because these two wires are broken. They might have been touching, could have burned it, or something else caused it. So we want to figure it out, because sound chip, it's kind of a generic chip. I can order one and resolder it to the board. I don't know if this one works or not, since the speaker is not attached to it at the moment. I don't feel like energizing it till I determine what caused the burn. Also, I got to figure out what ohmage this resistor was, because this resistor down here is completely burnt, as in there's nothing left of it, except for the two ends. The resistor up here and this resistor here, they're burnt, but I can still make out the color code, and they still have resistance, which means they're, you get an idea. You can see how close they are to tolerance from the color bands that are on there. I'm going to replace them because they're burnt, which means their lifespan is extremely shortened. So I'm going to try to do my best to hold it up, shine a light if I need to, which is right here, to give you an idea what I'm looking at, so that way if you have this piece and you have something similar, you have an idea what to look at. Now these two pieces are still attached. You can see the wire right there. So I'm going to try and loop my hand through and hold it. Might be too much of a glare, but there's a resistor right here. This resistor is on the back side of this little board, which has a diode, another resistor, it looks like a Zener Diode, and a transistor. It's attached to the white and black wires, which go to the bottom of this board and then up through the center. What confuses me is the white and black wires right there coming out of the center post are twisted together. Generally, white and black wires would be two different polarities. That might be the reason why that resistor is burned. It's a short. The other resistor is the bottom side of this chip. This chip is the sound chip. You got two resistors right there that are beautiful colors. You can see the colors are fine. Then you got this little bad boy. That's got a hole blown through the side of it, and it's kind of silver in color because it burnt all the coating off of it. I have no idea what that resistor is supposed to be as far as resistance wise. And the last one, which I'm going to probably see if I can just zoom the camera down, is down in there. I want some support to try and hold this center barrel. So let's see. Where is it? There we go. I'll recenter it in a second here. Only got two hands. Now I knew about this resistor that I'm going to try and focus. Yeah, it might be too close. Let's back it out a hair. You're going to focus. Somewhat. You look in here, this one way over here, still blurry. That guy right there is burnt. Yeah, I don't think zooming in is helping much. Yeah, it's about as close as I can get where the camera doesn't just go out of sync. That resistor right there is burnt. Those two are fine. That blob chip right here on this circuit board has light wires that go out to like this ring right here. You can see all the little LEDs soldered in and soldered together and then glued in for alternating flash patterns. I've seen this blob chip used on a few different pieces, or this style, this little circuit board with the multiple contacts out and only 2 or 3 of them used. To help doing alternating or rotating patterns of LEDs. So that's what I'm assuming it's for. I've never seen one of these in function fully. I'll probably have to do some Googling to find out what the lights are supposed to do. But, so we have 3 burnt resistors. This is a light resistor. All of these up here are light resistors. because we have a ring of lights here, right there. Show you when it's on camera. You have a ring of lights here, and I believe there's some lights on the roof. Yeah, there is. And then there's some lights that protrude through, that stick up through the top. So those 3 resistors, which the 2 that are still good have 2 different color band sets, or 2 different color codes. They're probably different colors, so they have different forward voltages and different milliamp ratings for their lighting. Or they just do it to increase or decrease the amount of brightness. We'll figure it out. So, gotta figure out why this guy is smoked. Still has resistance, but something is making it get really, really hot. And so, and then of course what damaged, slide it back into frame, what damaged that resistor right there. And that resistor right there. Of the resistors, this is the best of them. It's not burnt all the way through, it's just discolored all the wires and the casing. The other ones have really burned. So I'm going to get a piece of paper and do some testing with the meter and figure out what the resistances should be based on the color bands that I can read, and then try and figure out what the one resistor does that has no color bands left. Do some tracing of the tracks. That's basically where you take the circuit board and you trace the tracks and see where it goes. And then I'll probably have to look up the chip to find the chip's pinouts. A lot of times the chips will tell you to use certain types of resistors or transistors or capacitors on different pins, and sometimes that can help narrow down what that little resistor is supposed to be as far as an ohm reading. Or it'll give me a range, and I can start in that range, solder it in temporarily, hook the speaker up, and see if I get the correct sound, whether it be volume-wise or speed of the sound. But I wanted to show you that before I plug this bad boy in, I got to do a lot of tracing back and forth. And to trace back and forth, you just got to follow the wires and then follow them all the way around, follow them to where they connect, and then trace them back down to their signal, which is going to be from the bottom here, because that's where the power plugs in. And see if you see anything that's shorted, broke, and then if not, that you can visually see, then you can use a meter and use the resistance to see if you have continuity. The easiest way to do that is to desolder one of the wires off of the circuit and see if you got continuity, because you can get continuity in both directions, both across the component and the other way around through the circuit board. But instead of spending the next hour or so doing this on camera, I'll try and figure out what I can, and I'll show you the process, because it'll be more streamlined at that point, and we'll go from there. But at the moment, I'm not going to plug it in, even though I do have the power supply that I was talking about. Here's the end of it. I don't want to plug it in for fear of doing more damage to it. I do not want to sacrifice that main blob chip that controls everything. So, we shall return once I hopefully figure out where the problems are that are causing those 3 resistors to get hot and burn. The only other time I experienced this on a Lemax where the resistors were burnt was on a front yard scene, and the front yard scene, the LEDs had shorted. A lot of times when LEDs pop, they open, so there's no more path for electricity to go through, and the LEDs were shorted, and it was pulling a lot more power than it was supposed to, which caused the LED to burn. And I mean, it burned, it smoked, and it burned right through the bottom of the front yard, which I believe I showed that on one of the previous videos, the repair on that. So, similar process, tracing it back, finding out what failed. I can't imagine an entire string of LEDs failing, but it's first time for everything. So shall return. Okay, we're back, or I'm back. It has literally been 3 hours of me going through all the components and circuitry in here to try and figure out what happened. And after tracing all the burns and all the damage, overheated wires, the brittle connections, the bad solder, etc. I think I figured out what happened, and now I have to figure out how to fix it. So, speaker. This little resistor that's burnt next to the chip, one of the first ones I showed you, is the two speaker wires touch each other. That goes to the output of the speaker, and most likely what it did was it shorted out and smoked. That's why there's no speaker in here at the moment. It's over here in that case. So that's most likely what happened to the speaker resistor. Now, I've been schematicking the circuitry so I can try and trace the failures and also figure out what they do. So, I mean, I've literally been sitting here getting all the components. So this main circuit board, this big guy right here, it's got 6 solder joints across the top, which they're mostly there for the blob chip and the amp. They also act as a pass-through for power and ground to the smaller circuit board and to the lighting on the top, which makes sense because it comes right off of the plug over here, which is the incoming power. So anyhow, the capacitors are on here. There's 4. There's 3 bigger capacitors right there. You can see the shine of the tops. Then a little small ceramic one in between. The 3 capacitors, 2 of the taller ones here are 10 microfarad. Third one's 100 microfarad. They're printed on the side. It's easy to figure out. The ceramic one, though, does not have a marking. So, how to use a capacitance test. It's coming up at 73 nanofarads. Give or take 10% for most electronic components, just to give you an idea in case you have to replace this for some reason. You open this up and it's melted. It doesn't say anything on the side. There's 2 resistors this side of the chip. Let me see if I can zoom back down again. It'd probably be easier for you all to see if zoom. There we go. Alright. Get this piece in focus. So here we go. Burnt. 2 right here. And then there's 2 more resistors right there. The ceramic capacitor is that thing down there, to kind of a brownish tan. So this one, not a clue what the resistance was. Right now with the tester, using it to meter, which is off screen now, it's 5.5 megohms, which probably really too high for something this small. These 2 resistors on the right, one is 1.1K and one is a 1.0K, or 1,100 ohms and 1,000 ohms. The 2 down here, starting this one on the left, is, where is it? Is also 1K or 1,000 ohms, and the one on the right is 375K, which I thought was wrong because that's what my meter was showing. And then I looked up the color bands just to make sure I'm not blind, and yeah, it's a 375K ohm little itty bitty resistor. This chip is an amplifier chip. It is a D2822 amplifier chip right there. So if you open yours and it's burnt, you can replace the chip. I found them on a few websites for a couple of bucks. So most of these parts are readily available. That blob chip, the brain, unfortunately is not. So don't break it, or hopefully it doesn't get burnt in your unit. Alright, over here on this little bitty circuit board, is you have, I told you, the resistor, a transistor, and then 2 diodes. And there's actually 2 resistors, one on the top, one on the bottom, sorry. Both resistors are 150 ohms each, and they're actually parallel to each other on the same circuit, which means that brings it down to 75 ohms of resistance on this little circuit board right here. Because when you take 2 resistors and parallel them, it cuts the resistance in half. So the transistor is a 1815 NPN transistor. It's a very common transistor in most Lemax Department 56 pieces, as an example. Mr. Christmas, so on. Standard, you can get them for literally a quarter. Shipping costs more than the unit. The diode that I said was a Zener diode is a Zener diode. It's 7B2, B like boy. It's a shunt diode. It's used as a shunt, so it's also readily available. The resistor on the bottom is what burnt. The resistor on the bottom and the top, since they're parallel to each other, go up, which does the light inside of. I'll zoom out so you can actually see what I'm pointing at. Wrong way. There we go. So these two wires right here are the light that goes inside here that illuminates. Then it sends the power, it receives the power from this main board, and then it sends the signal up through these wires here, which I still believe are wrong, because the black wire is negative and the white wires are positive, and they're soldered together. So I think this might have been open at one point. Not a good idea. That's a short. That might be part of the cause. But that could have been done after the failure if somebody tried to fix it themselves and they broke the wires, because this chip up here got hot. So anyhow, once it goes up inside, it then also sends signal to this, and then this is supposed to make the UV lights flash back and forth in every other light pattern. All the lights on the top appear to be solid, which I've looked at a couple different videos, are all solid, if they even work. Apparently a lot of them don't work. But they're wired to that chip that makes them alternate. So I'm having a slight issue in figuring out if they're supposed to alternate or not. But they all do work. Every single light in this thing does turn on. That's what I was unclipping when I was doing that, was pulling the after testing all the lights. So anyhow, the basic schematic for that circuit board down there is the standard diode, which is a N4004, which is another standard diode. That goes to the black wire on the motor, which the motor is now over here because the wires came off. Everything's brittle because it got hot in here. The white wire that's dangling over here, one white wire goes to the motor, and the other white wire goes to the other circuit board. They are marked. I put a little Sharpie on them so I know which is which. I also did it to this. You might be able to see the colors. Reason being is the solder joints on these are horrible. I'm probably going to have to replace most of the wires anyway, because these wires are so fragile. And then down here, where they're brown at the bottom, that's from the heat. Makes them very weak. So they're all going to get replaced. So, from what I can tell on this unit, as well as a Department 56 had a very similar issue because it uses the same exact chip. The chip probably shorted out, or something shorted it out. One of the wires may have broke in advance, which then backfed down the center to this. This got really hot, which is soldered or glued right next to this board. Possibly the heat from that caused a failure on one of the speaker wires, or that's just coincidental, which then shorted out the speaker, shorting out that resistor, and causing it to smoke. As far as this goes up here, the reason there's actually, I thought it was just one burnt resistor. There's three. Three other resistors are burnt. One of them doesn't work. The other two still have good resistance within the bands, but they're probably burnt from they're all glued together. So when the one got really, really hot, it started melting the ones around it, of course. And the hot glue that it's glued in with started to separate as well. So I'm going to have to replace, I don't know, 5 resistors, maybe 6, to get most of this working. I probably won't be able to make the light pattern be the same. I am going to try. I don't have the circuit diagram for that chip, but I know what it does based on the videos, and they make alternating flashing circuits. So it goes left, right, and these lights go every other one on, every other one off at the same time, which is left, right, left, right. So I'm going to see if one of those will power all these lights. If it does, we're good. If it doesn't, then I'm going to have to make them solid, unfortunately. Because the chip they use in here, in this blob chip, is somewhat proprietary. I have tried finding them. I have tried scraping that stuff off the top of it and the previous one with no avail. There are some other circuits out there that can do the same flip-flop, but they pull more than 4.5 volts of power. Somehow, Lemax uses a 4.5 volt input for the chip that it says this is, says it runs at 9 volts. Like that. So I know it's not the same chip that I'm finding online. But so I'm going to try and doodle some circuits and build a couple things and then plug it in and see how it works. See about bypassing that chip, getting the lights to work, soldering new resistors in, trying to get this part functional first, the lighting. Then I'll work on putting the motor back in and the sound, because I still have to find what that resistor could be. That guy right there that's burnt. All the diagrams of the chips, none of them show an approximate value. So I bet you the approximate value is based on the voltage coming in, because that chip can handle a really large voltage range, as well as the ohm rating of the speaker it's attached to. So speaker ohm rating is pretty easy. It's written on the back of the speaker. So I'm going to have to do a little bit more research. But I have literally diagrammed and looked up every component. So that way, if I have to break all the wires off or they all fall off, I know how to solder it all back together in the correct order so it'll work like it's supposed to. And there's the other one. So that's where we're at. How I was doing all the testing was, one, I pulled the boards out as you saw, they're dangling, and hit them, wrote down what I could read with a pair of magnifying glasses, because a lot of it's labeled. There's things stamped on it, except that unless you have really good eyes, you're not going to be able to read it. Wrote everything down. Then I took the flashlight from behind, and you might be able to see it, but you can see the tracks. And then I just started tracing the tracks, finding the components, moving them around until I made those schematics. Technically, because it's on a circuit board, I don't have to do that. The only reason I was doing it is so I can trace the wiring from one board to the other and see where it goes to within both circuit boards down here. That way I can see what might be causing the issues, what might be the problem I need to fix, and which components may or may not need to be replaced. So, also, by getting all the components and giving you the names, if you open this one up, you know, if you can't read it, the chip is a D2822, the capacitors are 210 microfarads, 100 microfarad, and a 73 nanofarad for the one that's not marked. You know, on the smaller board, the diode is an N4004, which is a very common diode. The transistor is an C1815, which is a very common and all Lemax transistor. And then the two resistors are 150 ohms each on that small board, meaning 75 ohms total since they're parallel. So this one is going to be a little bit more difficult than the other ones because of the small little fires, quote unquote. So, but we're going to continue. I'm going to test out the circuits and see if the little flip-flop circuit can handle 6 UV lights, because UV lights draw a lot more power than a standard like red or green light. So, if it works, I will swap out that chip up there for something that is functional, and then we'll work on the rest of it, and then we'll have to deal with that broken gear and see what we can do about that. So, shall return. So see you shortly. Okay, to replace that blob chip that's not functional, this is a flip-flop circuit, and as you can see, it's changing the back and forth the 3 UV LEDs. This has 4, but the load on it would be about the same if this was just to test it. I took the factory circuit that you can buy and removed the capacitors. I've taken out the 47 microfarad capacitors and replaced them with 220 microfarad capacitors, a little bit larger as you can see in this picture here. There you go. Which slow down the flash rate. So it's closer to what this had originally. I can't tell on the blob chip that's covered. I'm going to show you it right here. That's it. What else it did, because every video I've seen, all the external lights are solid or they're not on. So I'm not sure if this makes them flash slowly or not, but this doesn't work anymore. You send power to it, nothing lights up and no outgoing, so the little chip that's inside here has burned out. They still have good continuity on the one resistor on the back, and this is one of the resistors that's getting replaced because it's still good, it still registers good, but you can see it's discolored from the resistor next to it burning. And I'll show you that one. Let's see if we can get it to focus. So it has melted through, has no resistance, well, no good resistance. The resistance level on that is like 470 megohm. It's ungodly high. And then this resistor was attached to it as well. This one is also discolored and burnt. Basically every resistor in the top of this unit has been slightly damaged. This one, it started melting the casing. Still a good resistor as far as it functions, but because it has damage, it's going to shorten its lifespan. So they're all getting replaced, like I mentioned earlier. But I wanted you to see, since I've cut them all out and replaced them. But this circuit board here, which I know is a lot larger, is going to replace that blob chip circuitry. Because that's all I can find. I don't know what the blob chip is made out of or what the circuit is inside. I have an idea, but I can't verify it. I might try and scrape the blob off and see if there's anything underneath that I can find. So, at the moment, I'm going to stick with this. I'm now going to connect the UV lights that are supposed to flash to this circuit, then hot glue this circuit to the inside of the unit. I may remove this incoming terminal block and solder the wires directly to it if I have a clearance issue because of how high that sticks up. If not, I'll just hook the wires to it and have them run down to the bottom and then hook them up to the, of course, incoming power source from this unit. So, next is to continue, get this in, and then put the rotating mass back inside and then work on that gear. But I wanted to show you, this is called a flip-flop circuit. You can buy them on eBay. It's like $10 for 10 of them. I couldn't find them individually, which is fine. I've used it before in other pieces, one other piece actually. So, and by changing the resistor or a capacitor, you can increase or decrease the speed and the brightness of the lights. So, next time when I show this, it should be assembled with working lights, and then be working on the gears and trying to make the rotation function like it's supposed to. Okay, the Scare-Ousel is back together with all its new lights. Unfortunately, no matter what I tried, I cannot get the sound to function. The sound is gone. The leg that comes off the blob chip that goes to the amplifier, no matter what resistor I use, I cannot get a good enough signal to cause the sound chip to activate. So, the sound chip will produce static, but it will not produce the audio track that was built into this unit. Excuse me, but it does function. It's loud, but it's all original. It's the original motor, original set of gears, the whole nine. It's just new lighting. That's all I was able to repair was the new lighting. So, volume's all the way up. There it is from the top. These lights are on, they're just dim. There's all the side lights. And you can see the carousel is turning. We'll turn on the we're going up and down. All the lights on the deck are functioning. All the green. The UV lights are flashing. You can see that in the camera. The center is lit up orange. So, and then these lights have been replaced. These are backlit. These are like fiber optic. They are, there's LEDs glued to the backs of these. And this is a plastic stem that they then wrapped like a little piece of wire around to make it look remote. So they are dimmer than the rest, but they are on. It's just that it's just using it as a fiber optic where you have the light on one side and a clear piece of acrylic going through it. So this is as good as I can get it for something that caught fire, basically. I'm going to turn on some lights and take you show all the components. Here is the transfer board that no matter what I did, I could not get this transfer board to send power to the motor, so I had to bypass it. And here are all the resistors that were burnt. There's 5 of them. 5 of these guys were smoked inside this house. This is why if you have a house that doesn't work, like the ghost around especially, where the motor fills with the grease and then it stops turning, but if you turn the drum, it'll make the lights light up. There's no fuse, so if the motor fails or quits or gets bound up, meaning the gear broke and it's not turning, this thing is starting to draw more and more power. It's pulling more and more power from the AC adapter. Something is going to give out, and in this case, a whole bunch of components went bad. We're talking 5 different resistors. All these resistors controlled the lighting. None of these were for the motor. None of these were for the sound. This was part of the motor control. This doesn't function. It has a burnt resistor and the transistor has failed. So this is also bad. So I have removed it and just redid the way the motor is wired in. You can see it rotates. This is the blob chip that controls the flashing lights for those UV flashers that are under the lip. And then I showed you I glued in a flip-flop circuit, one of these that you can get on eBay. They're called flip-flop circuits, and that's what's replacing this. This is much smaller, as you can tell, but there's plenty of room in this canopy to fit an aftermarket build your own part. This, of course, being integrated circuit, I see it's a lot smaller, and it's probably just a single chip that does what all these components do, minus the LEDs. The LEDs, of course, are underneath the lip, and that's what these wires would go to, as an example. The 2 are hanging off. So it does turn, it does light up, does not produce sound. I have tried everything I could think of, but I'm getting no signal out of the blob chip to the amplifier. The speaker and everything's still in here. It's still in the bottom. It's right there. The clunking you hear is the characters moving back and forth on the metal shafts. And if you can find a broken Scare-Ousel somewhere that has a functioning circuit board, you can just desolder and resolder a new circuit board. So maybe one day in the future, because it has happened, you probably saw the rave at Graves, where a parts house was found that was shattered, but the internals were still good. We're able to make one good house out of 2 broken houses. So if we can come across a Scare-Ousel, maybe we can swap the circuit board out. I'm not going to worry about the lighting part, this thing, because I really don't want to take the whole thing apart, but I'm more concerned about the motor control and the noise. I think it's because the motor control slows the motor down, and this thing is running at full speed. That's as fast as that motor can go. Any faster than that, you'll start to burn the motor out. So this is kind of important, but I can't fit a motor control aftermarket in there. It's too large to fit in that small space. This motor is designed to run up to 6 volts. It's running at 4.5 volts, so it's totally fine. At 6 volts, it spins a little bit quicker, but I wouldn't run a motor that fast in something like this for very long because it will get hot and wear out faster. So, but the little hobby motor that's in here is rated 3 to 6 volts. It's running about 4.5, so right in the middle. I think this probably ran it closer to 3.5, honestly. Based on the video I can find of this unit, this does spin slightly faster because there's no motor control circuit. Lighting wise, my flash pattern is not as slow as theirs, but it's close and it works. And I couldn't tell from any of the videos I saw, but these lights up here, it had this one looked like it was broke off, or they had a plastic bar shoved in it, so I replaced this one with an LED. So it's possible this light here is not in the actual unit originally. It is now, so this one's special. It's got more lights. The other thing I noticed is I've seen several videos on YouTube and auction sites of this piece, and all but one, all these lights are out right here. And I don't know, maybe they're supposed to flash on and off and they're controlled by this, because this was soldered to every light in the top canopy, or they're defective. Unfortunately, I can't find a good quality video or anybody that has this part that can show me the actual function. So this is built as close as I could do based on all the videos I could find from Lemax and other YouTubers and other auction sites where they show videos of this functioning. So lighting, motion, done, no sound. Hopefully in the future we can find a parts house. I always look for them and buy them because parts are important. And if I find a Scare-Ousel, I'll contact the owner and see if she wants me to send her the circuit board, if she wants to try and swap it herself, or if she wants to send this back and I'll swap the circuit board out for her so we can get the soundtrack back in, which will help muffle that motor sound. So until the next one, thanks for watching. Have a good one.